email me. This is very important. So we do cover 8.6. Since today we have time for 8.6, and then so that will be the main goal for today is to finish up 8.6. Anyone have any questions for me with your finals here?
So what will we do next Monday?
Review.
Oh, okay.
So on next Monday, we will review for your finals, which is right over here. Okay, so next Monday, we'll review for your finals from 2 to 3:30 at the same time. And then after that, on Wednesday, you take the finals. Questions? Anyone have any questions? So today we will start, we will do the last section for today's class, which is 8.6, where we will write trigonometry form of a complex number. So this is, again, when you do chapter 8, we talk about law of sine and law of cosine. Those two are kind of like together. And then we also talk about vectors, 8.3 and 8.4, the dot products, you know, the scalar, the linear combinations, the component form. So they are all together. And then 8.6, this trigonometric form of a complex number is also by itself. So that means that they are not really related between the law of sine, law of cosine, the vectors, and the complex number in the trigonometric forms here. So they are three a little bit different. So a lot of students try to put all these three together, and actually they are not together. They are kind of like three different, you know, branch. You know, they are not very similar. So what is you guys know a complex number? So a complex number in this case is written down as an a plus bi. Okay, so this is the complex number, a plus bi, where a in this case is the real and the bi is the imaginary. Okay, so a complex numbers do have the I part, the imaginary part. So if you want to plot this a plus bi in what we call as a complex plane, in the complex plane, the horizontal axis is the real axis and the vertical axis is the imaginary axis. So for example, in this case is if you have a complex plane like x and y, so instead of using x and y, the x in this case is the real and the y in this case is the imaginary. Okay, so if I want to put a where is a plus bi is just a coordinates, where your a in this case is the real and your bi, your b in this case is imaginary on the imaginary axis. Okay, so example of this complex plane in this case is if I call you guys to do where do you graph the complex plane for this case, 3 minus 4i. So in order for us to find, to graph this on a complex plane, the real is the your horizontal, the imaginary is your vertical. No. Yes, vertical is your imaginary. So 3 in this case will be here. So 1, 2, 3. And negative 4i is 1, 2, 3, 4. So this is negative 4. So the location of this 3 minus 4i is right here. This is where z. So it's very similar to coordinates. So instead of giving 3 negative 4, so this is written down as 3 minus 4i. So the first few questions when you do 8.6 homework here is they will ask you to graph this. And in order for you to graph this, it's just a coordinate point. So this point. So don't draw a line. Don't do anything. It's just a coordinate point. Okay. But if a question is asking you to find what is the absolute value, absolute value means is the distance from the origin to the point AB. Okay. So the question is sometimes to start finding out is what is the absolute value or the distance for this? So in order for us to find what is the distance for this, you just need to use your distance formula, which is the square root of a squared plus b squared. Okay, so a squared plus b squared. In this case, A will be 3, so it will be 9. 3 times 3 is 9. And B in this case is -4. Ignore the I. We don't use the I here. So your B in this case is -4. So -4 times -4 is 16. So this is square root of 25, which is same thing as 5. So this is the distance of this complex plane. Okay. The formula is square root of a squared plus b squared. So you can write this trigonometric form to a complex form. So the trigonometric form of a complex number is given us by this r equals to cosine theta plus I sine theta, where A in this case, if you distribute, A is your real. So A in this case will be your r cosine theta, and B in this case will be your r sine theta. And if you want to find what is r and theta is, r in this case is the absolute value, which is the square of a squared plus b squared. So the one that we just found out here, the distance in your complex, in your trigonometric form, this is called as your r. And we have a name for that. We call it the modulus. Okay. So the number r is the modulus. So modulus, distance, absolute value, this square of a squared plus b squared, they are all the same thing. Okay. And then in order for you to find the theta, the tangent theta, this is what we call, we use tangent. And the reason why we use tangent here is because if you draw your right triangle, the right triangle here, this is using TOA because tangent is opposite over opposite over adjacent. So that's why tangent theta in this case is b over a, and the tangent, the theta, after you do the arctangent of it, the theta in this case is what we call as your argument. Okay, so one is called a modulus, one is called an argument. Just want to point out again, very, very special here is make sure you know that the theta is in the in the correct quadrant, and make sure you also know that either what angle you use, either it is in degree or is it in radian. Okay, so sometimes your question want us to write your answer in degree, and sometimes they want you to write the answer in radian. And also usually this is going to be from 0 to 2 pi. If you're talking about radian, that means that if your answer is 0 to 360 degrees, so it depends on what type of degree of radian they use. So in my class, usually I will just stick it with degree. So so what I want to point out to you is in your calculator, just set your mode to degree mode, especially when you do my finals, because we'll concentrate more on in this case using degrees. But when you do your online homework, sometimes they want it in radian, sometimes when they want it in degree, then you have to keep on changing your mode in your calculator, either to degree or to radian. But what is mostly important here is make sure you figure out the quadrant in this case. So for example, like this case, we found out that the modulus or the r in this case is 5, which is the distance from the 0, 0 to the z. So this is the r. In order for us to find the theta, now the theta that you have in this case is going to be this theta. This is a theta we're looking for because it is go from 0 to 360. So in order for you to find the theta, we will use tangent theta. In this case is b over a. It's not a over b, it's b over a, which is the I imaginary over the real. Again, don't use the I here. So b in this case is -4, and a in this case is 3. And then after that, you move the tangent over here. So that will become the arctangent. Okay. So when you guys use your calculator, and let's say I want this in the degree mode. Okay. So that's why, so take out your calculator. And I want you guys to figure out what is the arctangent of -4/3 in degree mode. This is what students do wrong in my test is they give to me in radian. So that will give me negative 53.13 degrees. If you put this in your calculator. However, negative 53.13 degree is wrong because you are calculating this degree that goes clockwise. Because if you remember, negative degrees, negative angles means you go clockwise. But we want to go counterclockwise. So this degree, in this case, you have to add 360 degrees because then you want to go the other way. So this theta in this case will be plus 360 using your answer here, 306.87 degrees. 306.87 degrees. So this is the correct degree in this case. So that's the reason why that when I put it down here, make sure your theta here is in the correct quadrant. That means that if you sometimes your calculator does not provide you the correct quadrant. This is in quadrant 4. Sometimes they give you in quadrant 1 or something weird quadrant, so you have to change it back. Okay, so so what happened is that we can write this trigonometric form into this complex form into the trig form by doing finding the modulus and the theta. So in this case, if you look at your formula here, it says that it is your z in this case can be written down as r, which is 5, times cosine theta. And again, the theta in this case is 307. I just used 307. Plus I sine 307 degrees. Okay, so this is your complex form written down in trigonometric form. Okay, so you have to figure out your r first and your theta. So r is the distance, the theta you use the arctangent, and then you just watch out for your quadrant. Okay, and this is then once you finish, you put r cosine theta plus I sine theta, just plug it back into the formula here. And that will be your complex to trigonometry. Okay. If you want to go the other way around, means that from trigonometry to complex, then you just use your calculator and type what is 5 times cosine 307. And what is 5 times sine 307. Okay. So when you type in, when you use your calculator, the 5 cosine 307 will give you your answer very close to 3. And then the 5 sine 307 will give us negative 4, very close. Okay. So if you take 5 times cosine of 307, you will get like 3 point something, very close to 3. And then when you do the sine 5 times sine 307, you will get the negative, around close to negative 4i. So transform from trig to complex is very easy. You just distribute your 5 and then use your calculator to figure out what is 5 cosine of that and what's 5 sine of that, and you will get back your complex form. But from complex to trig, you have to do some work. You have to do the distance and you have to do the theta. So this is a bit more work here. So usually in the test, going from complex to trig is what I'm asking for. But going from trig to complex is very easy. You just, put in your calculator. Now, because of this is a lot to write. Okay, 5 times cosine 307 plus I sine 307 plus I sine 307. So we can short form this. So there is a shortcut to write this. So the shortcut in this case will be written down as 5 CIS 307 degrees. Okay, this is a shortcut to write this. The 5 is the R. The 307 is your theta. The CIS stands for cosine plus I sine. Okay, so the CIS is for the cosine plus I sine. Okay, now please do not use this in your online homework, because your online homework will mark you wrong. They don't understand this shortcut form, the CIS form. But in the test, if you are running out of time, you don't have time to write 5 cosine 307 plus I sine 307, then you use the 5 CIS 307. So in this case, you can write this form as R CIS theta. Okay, I just put that in parentheses. So this is the same thing as R cosine theta plus I sine theta. So in this class, I use a lot of this CIS form. That will be the fastest way. But then when you guys do it in your online homework, make sure you use it type out the long way like this. Okay. Questions with this one? So now let's do question 1. I want you guys to plot 5 minus 12i in the complex plane. And then after that, I want you guys to take this and convert this into trigonometric form, which is the CIS form, the one that we just did. So go ahead, and I want you guys, it's very similar to this question that we just did. So go ahead, plot this in here. Don't forget, this is real, this is imaginary. So complex plane is always like that. And again, this is the basic stuff of changing complex to trig. And if you doesn't know how to do this, 8.6, you're pretty much goodbye. So make sure you guys know what to do. So can someone tell me where is this Z? I just put Z again here. Where is this Z at in this complex plane?
I.
What quadrant? So don't forget, it was a point like this. Remember, this is a point. So where is this complex 5 minus 2i at? Your real is 5. Your imaginary is where? Negative 12, right? So this is at where?
Quadrant 4.
At quadrant 4. So this is it. Don't draw me a line. So when you do in your test, you just, it's a coordinate point. So a point like this. Okay, don't draw lines like this. Don't draw anything. It's just a point. So this is your Z point, 5 minus 12i in your complex plane. Now we need to write this in the trigonometric form. So you need to know your R and your theta. So how do you find your R? This is how you find your R. R in this case is the distance. So you just take square root of a squared plus b squared. Don't forget, this is your A, this is your B. Okay, so this is your A, this is your B. So what is this gonna be? A squared. A squared is what?
25.
And B squared is
144.
And what is that gonna give us?
Square root of 169, which is 13.
Which is 13. So this is your R. Your R in this case will be 13. So this is 13. Now we need to find your theta. So in order for us to figure out your theta, you do the arctangent of B over A. Okay. Again, B in this case is -12. And A in this case is 5. So can someone, and again, I want it in degrees. Again, when you do your online homework, if they want it radian, change your mode to radian. So what is arctangent of 12/5? -12.
-67.38.
But that is not the correct form because it is a negative. So how do we figure out your theta in this case?
Plus 360.
You add 360. So your theta in this case will be 292.62. So now we got theta, we got R. We can write this in the trigonometric form. It will be 13 CIS 292.62. Or you can write 13 cosine of 292.62 degrees plus I sine 292.62 degrees. That's what you do in your written homework. So what does this mean in your graph here? It means that the distance from there to here is 13. And the angle from here to here is that 292 point. This is the meaning of how you write this into the trig form. Is you need to know the distance and the angle formed by this complex form. So it's pretty much straightforward type. Okay. So if your theta is in quadrant 1, you just use it. You do not need to worry about that. If your theta is in quadrant 2, you have to add 180. Yep. Okay. If your theta is in quadrant 2, you will have to add 180. If you have in quadrant 3, you also have to add 180. If you have in quadrant 4, like what we just have done here, then you have to add 360. That's why we add 360 here. So make sure you guys know that when you guys do this in your calculators, depends on what quadrant it belongs to. So if it's quadrant 1, you just use back the same theta given in the calculator. If it's in quadrant 2, you have to add 180. Quadrant 3, add 180, and then if it's quadrant 4, is add 360. And again, if the question wants it in the radian, then you just need to add pi, okay, or add pi or add 2 pi. So don't forget, your questions can be in radian or can be in degrees in your homework. But I will tell you that in my test, everything is in degree form. Okay, so I don't want you guys to convert here and there and there and here. So you guys will get into just everything in degree form. So no need to worry about doing all this crazy stuff. Okay. Questions on this? Right. I want you guys to do question 2 on your own. Same thing. 4 minus 4 root 3i. So question 2 is calling you to do 4z. I just put z. Z equals to 4 minus 4 root 3i. Is that 4 minus? You know what? I'm gonna make things a bit more complicated because this is so boring. Negative 4 minus 4 root 3i. There you go. Okay, so question 2. I'll put negative 4 minus 4. I just changed a little bit because it's going to be in different quadrant because I don't want every time it's in quadrant 4. I want you guys to draw this picture on the complex plane. This is real. This is imaginary. And then after that, I want you guys to write this in a trig form. This is very basic. So anyone know where is -4 minus 4 root 3i in your complex plane? This is in quadrant 3. So that means -4 on the real and -4 root 3 on the imaginary. So this is your z in this case, quadrant 3. Now, I want you to write this in the trigonometric form. So you have to tell me how you figure out your r and your theta. Very basic material, but so the tricky part is a square here. So we have the square root and the square. So I don't see how many of you know how to do this. So what happens when you find r? You have to take the square of -4. So that will be 16 plus the square of this. Does anyone know what is the square of a -4 root 3? You get what?
12.
Not 12. So this is actually you square the -4, you get 16. And you square the square root of 3. Now square and square root will cancel out, you get 3. So this is actually 16 times 3. This is 48. So this is how we square this. So make sure when you have a square root and you're gonna square it, square the number, and then the root and the square root will cancel. So that's why you got 48. And what is 16 plus 48?
64.
And that is a perfect square of
8.
8. So make sure you guys know how to do this kind of squaring. Theta is, again, we use the arctangent of negative b over a, and b is in this case is -4 root 3, and a in this case is -4. So again, when you count the -4 and the -4 will cancel, so become root 3. So can someone tell me what is the arctangent of root 3 in degrees? Hmm?
Uh, 60, and then you add 180. So
Yep, very
240.
good. Very good. So this is 60 degrees, but again, 60 degrees is in the wrong quadrant because 60 degrees is in quadrant 1. So you have to add 180. Yes. So this, be careful. This is what I'm always telling my students. So this is actually is what, 240.
40.
So what is your trigonometric form in this case?
8 CIS 240.
Yep. There you go. You guys all right? Questions? Oh, yep. Questions?
Why do we add 180 again? I thought if it's in quadrant 2 or 3, isn't 60 degrees?
Because this is in quadrant 3, and quadrant 3 you have to add 180.
Oh, okay, got it. I thought we're looking at the degrees, not the z. Yeah.
Yep. So watch out for that. That's the one I always tell my students to be careful. Okay. So this is very important. So make sure you guys know this, and the applying is right here because we know z is in quadrant 3. So that you have to add 180. Questions? Now, so far your z I give it to you is either 1, 2, 3, 4, right? So you either add 180 and all these things. What happens if your Z is this question? So this is question number 3. Now your Z is 12i. 12i. Okay, question 3 is given as 12i is your Z. So I want you guys again, write this. I'll draw it. Draw this in the complex plane. That means this is real. This is imaginary. And write this in a trigonometric form. 12i.
Is it 12 CIS 90?
Yep. So where is it in your complex form?
On the y-axis up 12.
Yep. So this is a 12. So this is 12i, and the distance or the modulus in this case is going to be 12, because as you know that your distance is always measured from the 0, 0 to the point. So in this case, your r in this case will be 12. And this one, you do not need to do the tangent, arctangent b over a, because we know this is a 90 degrees. So that means that this trigonometric in this case is 12 CIS 90 degrees. So what happened is that if I give you the complex form is on the x or y axis, it's either the r is exactly the length from the 0, 0 to the point given to us. And then the angle is either 0, 90, 180, 270, or 360. Depends on where is your coordinates at. So if it's 12i, then it's right on the y. But what happens if I just give you negative 12? Can someone tell me where is this on your complex, and what is the your trigonometric form in this case for negative
12? Would it be 12 CIS 180?
Okay, so in this case, your point is on the other side of your x-axis. So this is actually is negative 12 by itself. So the trigonometric trigonometric function in z in this case will be 12, because the distance is still 12, but your theta in this case will be 180 degrees. Okay. Or pi, or whatever. Again, watch out what is the units they want, radian or degree. Questions with this? Okay. So this is the basic fundamental stuff. So once you got this, then we can do a bit more. So we can actually multiply, and we can also divide these complex numbers. So if you got two CIS form, Z1 and Z2, you can multiply this by taking the R1 and R2 and multiply it. And then you can, for angles, theta 1 and theta 2, you just add them. Okay. So if you multiply your two complex numbers, your modulus R, you multiply it. But for the theta, the arguments, you add them. But if you divide this, then you just take the modulus and divide it, the R's. And then for your angles, we just subtract them. Okay. So don't forget, in order for you to do this, this has to be in a CIS form. So if a question gives you in a CIS form, you can just direct apply this formula. However, if your questions does not give you CIS form, they give you the 12i or the -12 or something we just did, you have to convert it into the trig form, the CIS form, before you apply this multiply and divide. Okay. For example, is question number 7. So question number 7 and 8 is pretty good news, because both 7 and 8 are in the trigonometric form, the CIS form. So 7 is multiplied. So we will have 3 over 4 CIS pi over 3. Just write down in this form, it's easier to see. And then you multiply with 4 CIS 3 pi over 4. So since this is already in the CIS form, so what do we do here is we are multiplying. So your R's, we multiply. So you will multiply this. So 3 over 4 times 4. And then for your angles, we add pi over 3 and 3 pi over 4. So this is what happens for multiplying and dividing is you multiply this and then you add your angles together. So anyone know what is 3 over 4 times 4?
Three.
And then what is pi over 3 plus 3 pi over 4?
Pi over 12.
This will be 4 plus 9, 13 pi over 12, right? And that's your answer. Okay. So it's pretty simple. As long as your answer, your work is in the trigonometric or CIS form, then you can just apply this formula for multiplying, dividing. So on question number 8, we are dividing. So again, when we divide, what we do is the R, we will divide. But for the angles, we subtract. So it's 50. Don't forget, it's always a top one minus the bottom one. Okay. So this is what we do when we divide. So anyone know what is 3/9 in this case, if you reduce?
Over 3.
So this is 1 over 3 CIS of what?
30.
30 degrees. Okay, so this is your answer. So it's very easy, right? Okay. So again, yes, multiply and divide is very easy as long as it is in the CIS form. Okay. But sometimes it is not in the CIS form, then you have to convert to trig. Okay. And the bad news is you're going to convert to the trig form, the CIS form twice because you got 1 and 2. So every time when you multiply, divide, you need to have two CIS to multiply or divide. So that means you have to convert them twice. Okay. So this is something like question number 9. Let's do question 10. It's difficult. Yeah, let's do question 10. Question 10, we can divide this. We use divide, but you can actually do the CIS form. But the first thing is you have to convert the Z1, which is the 1 plus √3i, into the trigonometric form. And you have to convert Z2, which is the denominator, 6 minus 3i in the trigonometric form. So go ahead, convert this into the trig form and convert this into the trig form. And be careful with the quadrant. Okay, remember, you have to add 180 or 360, depends on your. Okay, do so. So this is part A, where you have to convert the Z1 and Z2 into trigonometric form. So anyone know what is the R1 in this case?
Root 3.
Square root of what? Not 10. 10 is wrong.
Square root of 4.
This a square is 1. B square, if you square this, is 3. This is a root 4. So in this case, it's just 2. So be careful with this. And it does have domino effects, means if your trigonometric form is wrong, everything down there is gonna, whatever you do next is wrong. All right, how about theta 1? How you find the angle for this trigonometric form? This is just root 3 over 1, right? Anyone know what this in degrees? We just did this.
60.
This is 60 degrees. Do we need to change? Do we need to add 180 or add 360 on this question?
No, because it's in the first quadrant.
Yes. So be careful with this. This is in quadrant 1 because so this has to be in quadrant 1. So the trigonometric form for this case is 2 CIS 60. Now repeat this one for the Z2. So you're going to find R2 and theta 2 here. So R2 is what? 36 plus 9, right? Which is 45. Can someone help me to simplify root 45? That will be 3 root 5, right? Theta 2, you just need to take your b over a, which is -3. Is your b, and a in this case is 6. So this is -1/2 because -3/6 is -1/2. So I just reduce this to -1/2. So use your calculator and figure out what is the arctangent of -1/2.
333.4.
Oh yeah, and don't forget when you use a calculator here, you came up to be -26.57. So you cannot use this because this is in the negative. So what you need to do here?
360.
You gotta add 360 because this is in quadrant 4. So that's why you will get 333.44. So what we have in this trigonometric form in this case is 3 root 5 CIS 333.44. So this is part A. We're going to do twice. And now part B, we need to divide. So what is 1 plus root 3i divided by 6 minus 3i? Because the question did, if you look at the question here, they don't ask you for multiplication, they ask you for division, right? So question 10 is asking for division. So what do we do with divide here is you take the trigonometric form for the first one, which is 2 CIS 60, degrees, and divide this with the second one, which is 3√5 CIS. That 333.44. Okay. So what you guys do when you divide? What happens to your R's? You just divide. So in this case, it's 2/3√5. Now, if you want to rationalize, you can rationalize this, but in my test, I'm not testing you rationalizing now. I'm testing you about this division. CIS, what happens to your angle when you divide? You have to subtract. So this is 60 degrees minus 333.44. Anyone got a calculator to help me with this one?
Negative 273.44.
So this is negative 273.44. Now, as you guys remember that I don't like negative angles, right? All your angles keep it as positive. So, so if you kind of draw this, can you draw this angle for me? Where is negative 273.44?
First quadrant.
Yes, this is actually go back to the first quadrant. Okay, don't forget this is negative 90, negative 180, negative 270. So negative 270 points. But we want to figure out what is this orange one. So do you guys know how to figure out this orange angle?
At 360.
So we add 362. So add 360 to this fellow, that will be your answer. So it'd be 86.56. So your answer in this case will be 2/3√5 CIS of 86.56 degrees. And the last thing we're going to talk about here is part C, is where you want, this is called the trigonometric form. Part C, they want you to do the standard form. So what happens to standard form is you just multiply in. So you just multiply what is 2/3√5 times cosine of 86.56 plus the same thing, 2/3√5 times the sine of 86.56, and you put an I next to it. So this is what we call as the standard form, is you just take what we have here and then just written it down, just multiply it. So take out your calculator again and multiply what is 2/3√5. And again, class, you might need to put parentheses on the 3√5 because it has two terms in there, or two things you have to do. So you need to, and then times with cosine 86.56. And then do the same thing. So 2 divided by 3√5 times with cosine of 86.56. That one came up to be 0.018. Okay. And then you do the same thing on the other one, but you change it to become sine. That came out to be 0.298. And don't forget the I. So this is what we call as your standard form. Okay. And the one with the CIS is called the trig form. So when you do my homework for this section, watch also on your test, watch what form they want. If they want trig form, then leave your answer as CIS. If they want in the standard form, then you just need to multiply using your calculator, and we should put an I next to your complex form. Anyone have any questions here? Right. Now, so this is how we multiply and how we divide. So the next session we're going to talk about is how we perform powers. Okay. So we call it powers. So powers means you square or you power it to the n. So if you have this z is in the trigonometric form. So if you wanted to raise it to the power of any power 2, power 3, power 4, you take the whole thing and raise it to the power of n. Then what happened is that your r will be raised to the power of n, but your theta is going to be multiplied by n. This is called the De Moivre theorem. Okay, so this is called the De Moivre theorem, where you do it for the powers. Okay, and again, class, this has to be in the CIS form. And if it's in the A plus BI form, you have to change it to the trig form, like what we did just now, and then power it. Okay, so this is called the De Moivre theorem. So the next question we're talking about here is question number 11 and 12, where they want you to use a De Moivre theorem to do the power here. Now, the bad news about question 11 is this is not in the CIS form. So you need to convert that into the trig form. So that is the bad news about that one. So let's do number 12 first, then we do number 11. So number 12, the reason why we do number 12 first is because that is already in the CIS form. So it is going to be very easy to use the De Moivre theorems here. So, so what's De Moivre theorem says if you have this in a power form? So De Moivre theorem says what? Your r become what? To the power of 8. But your theta is your angle is being multiplied by 8. In this case, because we're doing 8 powers. Can someone tell me what is 2 to the power of 8 is?
256.
256. And what is 8 times pi over 2?
4 pi.
4 pi. Do not forget that 4 pi, this is in radian. If you talk about 4 pi, how can you tell me where is 4 pi at?
The x-axis.
Is exactly what x-axis, which is exactly what angle? 0. Okay, so usually when you guys give me your answer here, your theta in this case has to be either between 0 to 2 pi or 0 to 360, depends on your angles, degrees or radian. Okay, so if you get 4 pi, you just need to change it to become 0 to 2 pi. And we know 4 pi means you go 2 revolution. So, so this is your answer in this case. So it's 256 cosine 0 plus sine 256 sine 0 with a pi. Okay. So just need to watch out is the rule says that your theta has to be in between 0 and 360 or 2 pi. Now for question 11, this one is a little bit tough is because you actually have to convert this into your trigonometric form. Okay. And then you can apply the De Moivre theorems after that. Okay. So I'm going to leave that to you guys, and then you apply the De Moivre theorems after this. Okay. So this is a bit more work, but you're still able to do this. So find the r and then find the theta, and then don't forget this is power 6. So that means your power here will be power 6, and then you'll be multiplying your theta with 6. You guys all right with De Moivre theorem? Okay, I want you guys to do it. You guys are quiet here. All right, I want you guys to change this to the to r and theta. Yep. Find me the r. Find me the theta. Two plus 2i. Take z is 2 plus 2i. So this is not top actually. Something new also for you guys. You will use this a lot in engineering. If you are going for engineering, we use this a lot. Where is R in this case?
Quadrant 1.
I cannot hear you, Kelvin.
It's 64 plus 64.
No. No. Do not distribute your 6. We just concentrate on the 2 plus 2i here.
The square root 8.
So it's square of 8, which is what if you reduce that? Two root 2, right? What is the arctangent B over A? So B over A in this case will be 2 over 2, right? Because your B is 2, your A is 2, so 2 over 2 is 1. So anyone know what is the arctangent of 1 is?
Degrees.
That is 45 degrees. And do we need to add 180 or 360 on this question?
No.
No, because this is in quadrant 1. So this trigonometric form in this case, I'm gonna do this 2 root 2 CIS 45. Now we're gonna do this all to the power of 6. Now we do the 6. So what happens when you apply De Moivre theorems for this case? Your R, which is 2 root 2, will be power what? 6. And then what happens to your angle, 45 degrees? You have to multiply it by 6. So can someone tell me what is 2 root 2 to the power of 6?
$16.
2 root 2 to the power of 6 is 16. So 2 to the power of 6 is 64, and root 2 is, yeah, this is 16. Make sure you guys have a calculator with you. There. No, 2 root 2 to the power of 6 is not as 512. This is 512. Okay. Do you guys know how to use your calculator to do this? 6 times 45 will be 270. Do you guys know how to use your calculator to do 2 root 2 to the power of 6 is?
Yeah.
Okay. 512, right? So again, class, make sure you're allowed to use your calculator here. Make sure you know how to use your calculator. Right, so this is what we call as a De Moivre theorem, where you power it. So in the complex here, we can do multiply and divide. We can do the powers, like what we call De Moivre theorem. And the last one we're going to talk about here is taking the nth root of a complex number. So in order for us to take the nth root of a complex numbers, again, your z has to be in the CIS form. This is the formula. So in order for you to find what is the nth root of a complex number, the formula is given us by zk over by n root r CIS of theta plus 2 pi k over n. This is for radian, and you can change the 2 pi to become 360 if it's during degree. And you have to substitute k in this case to become 0, 1, and 2. K in this case is talking about the roots. So they were asking you for how many roots do we want. So if the question is asking for cube root is 3. So that means you will have 3 answers. K is 0, K is 1, and K is 2. So you plug K is 0 and 1 and 2 into this, and you will get 3 answers. If you're having 4th root, then your K is 4. So you plug in 0, 1, 2, 3 into this formula. So again, in order for you to find the nth root of this, you will first put it in the CIS form and then apply this formula. Okay, I will show you what do I mean here. This is something like number 13 or 14 here. So so for question number 13, they want you to find what is the cube root for 8 CIS 2 pi over 3. Okay, so they want you to find the cube root for 8 CIS 2 pi over 3. The good news is this question is already in the CIS form, so you do not need to convert it to the trigonometric form like what we did before. So now we will use your formula here. So since they're asking you for cube root in this case means your n will be 3. So nth root, cube root, n will be 3. Your r in this case will be 8. Your theta in this case is 2 pi over 3 now because this is in radian. So we're gonna use this formula. If you use degrees, then make sure you change your 2 pi to become 360k. Okay, because it will be. So we just plug in this formula here. So zk in this case, it will be the cube root of 8 because n is 3. Plug it in. R is 8. CIS theta is 2 pi over 3 plus 2 pi k all over 3. Don't forget n is 3. So we plug all this n, r, and theta into this question. And your k is still there. There's only one k here. So then you figure out, and anyone know what is cube root of 8 is? Cube root of 8 in this case is 2. So what we do here to figure out your answers, you got cube root. So in this case, your k will start from 0, 1, and 2. Because when n is 3, you got 3 answers. Okay, don't forget cube root is like power 3. You should have 3 answers. That's what you guys learned in chapter 3. You know, x power of 3, you have 3 zeros. So this kind of like a zeros we learned. So what you do here is you plug k to become 0. So you will get 2 CIS 2 pi over 3 because our k in this case is 0. So that means this case is 0. So then you got 2 pi over 3 over 3. What is 2 pi over 3 over 3? 2 pi over 3 over 3 is 2 pi over 9. Next, you plug your k to become 1. So 2 CIS 2 pi over 3 plus 2 pi because your k is 1 all over by 3. Now take out your calculator and do what is 2 over 3 plus 2, the whole thing divided by 3. Okay, so if you're using your graphing calculators, you can just type this out and then put your math to fraction. If you use your non-graphing calculators, then you use your ABC. You take 2ABC 3 plus 2, put them in parentheses because you do that first, and divide this by 3. Okay. You will get a fractions. Those you're using your graphing calculators, you just take parentheses 2 divided by 3 plus 2 divided by 3, and then you do the math fraction, right? Go to the fraction, and you get your answer in this case. So it's just mostly a lot of calculators, a lot of fractions here. So 2 over 3 plus 2 divided by 3. Change the fraction. So this is 8 pi over 9. So this is going to be written down as Z1 in this case will be 2 CIS 8 pi over 9. Okay. And for Z0 is 2 pi over 9. For k equals to 2, you just do the same thing. So for k equals to 2, you just replace k is 2 here. So you got Z2, 2 CIS, 2 pi over 3. Now, because your k is 2, so 2 pi times 2 give us 4 pi and all over 3. So in this case, it's kind of do it again, but this time you don't have plus 2, you will have plus 4 because you double your k in this case. So if you do that, you will get your answer in this case. So in this case, it'll be 14 pi over 9. So your answer in this case for Z2 will be 2 CIS 14 pi. So this is how we do this kind of questions, applying the formula. Yes, it's a lot of work. So the first one is 2 CIS 2 pi over 9. This is for the first answer. Your second answer is 2 CIS 8 pi over 9 and 2 CIS 14 pi over 9. And again, class, I only allowed you to use CIS in your test and in my work, but when you write this in your online homework, you have to do the 2 cosine 8 pi over 9 plus I sine 2 sine 8 pi over 9. So it's going to be a bit more longer what you have to type. So make sure you guys know CIS is not used in your on your online homework. They don't understand CIS. They will mark you wrong. So this is what happens when the question provide you a question that is already in the CIS form. Okay. So what happens if a question did not provide you in the CIS form? For example, question 14, 4th root of 625i. Okay. So question number 14 is asking us to find what is the 4th root of 625i. So this is not in the CIS form. So the first thing you need to do here is to change this into the trigonometric form. This one is easy because 625i is not in your quadrant. So if you remember what you draw this, do you know where 625i belongs to? So it belongs up here, right?
625 CIS
625 CIS what?
90.
90. Yes, this is 625 CIS 90. So you have to change it to this form first. And now you replace, now because I'm looking for the 4th root, so n in this case is 4th, r in this case is 625. and theta in this case is 9. Okay, and we're gonna apply this using the formula of your the nth root, which is this formula. So it's given us by zk is the 4th root of r, which is 625. CIS of theta in this case is 90 degrees. Now we don't use 2 pi, we use 360k because our angle is in degree, over n in this case is 4. Can someone tell me what is the 4th root of 625? Now, if your calculator doesn't have 4th root is the same thing as 1/4, power to the 1/4. So if you don't have 4th root in your calculator, you just take that 625 to the power of 1/4. Okay, that will be the 4th root. Anyone know what is the 4th root of 625? 5. And you can reduce this. Can someone tell me 9? This is 90 over 4 plus 90k. So what we're doing here is I take this 4 and divide it by 90. 90 divided by 4, and I take 360k divided by 4. I got 90k. So this is your zk here. So now we will use, because we got 4th, so now we have k is 0, k is 1, k is 2, k is 3, and k is 4. 3, sorry. So when you have 4th root, you're gonna give 4 answers, 0, 1, 2, 3. Okay. So in order for us to find what is the 0 answer, the z0, you just need to replace your k to become 0. So you get 5 CIS 90 over 4. They want to know what 90 over 4 is. 90 divided by 4 is 22.5. Okay, so this is 22.5 degrees. When k is 1, your z1 in this case will be 5 CIS, and then you take 22.5 plus 90, because your k in this case is on the first one. K is 1 here. So when you take 22.5 plus 90, you get 112.5 degrees. Okay. When k is 2, z2 in this case will be 5 CIS. Again, you add 90 because 90 plus 90 will be k is 2. So 112.5 plus 90 will give us 202.5. So you can tell that the angles in degrees is much more friendlier, more easier to do compared to the one in radian that we did in question 13 here. Which will give, I mean, you can still do it, but it's just, you know, but as I mentioned in your test, I will want everything in degrees. So the last one, again, you add 90, so you get 292.5. So this is your answer for question number 14. Your K in this case will have 4 answers: 5 CIS 225, 125, 112.5, 202.5, and 292.5. Again, do not use CIS in your homework. They don't like it. Anyone have any questions here for me? I'm going to take attendance, so make sure you guys presence in there. The last 2 questions are very similar to what we did just now. So this one is asking us for cube root and 4th root, very straightforward. Like for question number 15 is also very straightforward. They're asking us to solve what is x cubed minus 27 equals to 0. So what we do here, class, if you have such thing, we just solve it. So we move the the x, the 27 over there, negative 27 over there, so it become positive 27. So you will get x cubed equals to 27. So again, this is not in the CIS form. So you need to figure out where is 27 if you want this in a trig form. This cube is telling us we are doing the cube root. Because in order for you to solve for this, you have to cube root both sides. So we're going to do the cube root of it. So does anyone know what is the trigonometric form for 27? This is also easy.
$27 CIS 90.
Not 90. Where was this 27 at if you draw it on the
X-axis.
on the x-axis? So what is the angle for the x-axis?
0.
0. 0 degrees. Okay. So again, since you're doing cube, so n in this case will be cube. Your r will be 27. And your theta will be 0 because this fellow is at x-axis. And then you apply this using your nth root formula. So zk in this case will be the cube root nth root of r, which is 27, CIS of 0 plus, we're going to use degree because it make your life a bit easier. 360 degree k over by 3. Okay, because our n in this case is 3, and then we reduce this fractions of this icky stuff. Does anyone know what is the cube root of 27? That will be 3. Now 0 divided by 3 is still 0. 360 divided by 3 is 120 degrees. Now remember last time on the previous question that we keep on adding 90 degrees. The reason why we keep on adding 90 degrees is, let me save this for you so you guys can see what's going on. Remember the previous question that we did, we keep on adding 90 degrees here. And the reason why we keep on adding 90 degrees is because of this 90k. So you see this 90, 90, 90. This is all because of him. So this is telling us that you just keep on adding that number to the next z, the next k. Okay. So this is how, so what happens for this question is you keep on adding what? 120 in this case. So when k equals to 0, z0 in this case is 3 CIS 0 because this is all going to be 0 here. When k equals to 1, z1 in this case will be 3 CIS 120 degrees because you will add 120 degrees here. The k is 1. And the last one is k equals to 2. You will get 3 CIS 240 because you'll be adding another 120, which is you get 240. So again, class, I strongly use the degree, except when you do your online homework, they might want you to put this use radian, and then you have to just convert all this into radian. But in my test, it's all going to be in degrees. So I'll just make your life easier. So make sure you guys do that in your test. The last question, number 16, is the same thing, but this time your answer is not as nice as 120 or all those numbers we just get. Because this, if you translate this into your trigonometric form, is not on the X or Y axis. So I'm going to move this over here. So x4 in this case is going to be -1 minus I. So I'm going to move this whole thing, the whole parentheses to that side. So kind of separating between the X and the non-X. So again, because this is fourth, so we will doing the fourth root here. Okay. And we have to convert this -1 minus I into the trigonometric form, like what we did in number 15. Again, it is not nice as what you did last time at 27 or something else, because this is in the quadrant now. To be more precise, quadrant. So can someone tell me what is the R in this case? And your theta in this case. So R in this case is a √2, right? 1 plus 1, 1 squared plus 1 squared. Theta in this case is arctangent of -1 over -1, because your B is -1, your A is -1. So this is arctangent of 1. And arctangent of 1 is 45 degrees. But again, you cannot give me 45 degrees because this is in what quadrant?
Third.
Quadrant 3. So how do we fix this?
Add 180.
At 180. So that will give me 225. So this trigonometric form is square root of 2 CIS 225. Okay. So now we need to find the fourth root. So that means my n is fourth. My R in this case is square root of 2. And my theta in this case is 225 degrees. Okay. So we will applying this to your ZK formula. Now the ZK formula say is the nth root of R. Okay, n in this case is 4. But R in this case is another square root of 2. And then we have a CIS of theta, which is 225, plus 360K divided by n. N in this case is 4, because we are doing the fourth root. Now, when you do this ZK formula, if you have a root and a root, and we know this is a square root, and this is the fourth root, because coming for the fourth. So fourth root and square root, if you do the root and the root, this is going to be an 8th root of 2. Okay, so this is the trick doing double roots. So you've got double roots like that, you just take the index and multiply it. So in this case, 4 times 2 is 8. CIS, again, this will, we have to divide this by 4. So 225 divided by 4 will give us 56.25 plus 90K, because 360 divided by 4 is 90. So this 90K telling us that every K you do, you just need to add 90 degrees. So your answer in this case will be, you got 4 answers. K is 0, K is 1, K is 2, and K is 3 due to your fourth root. Okay, so third root, you got 3 answers, fourth root, 4 answers. So when you get Z0, this is going to be the 8th root of 2, CIS of 56.25 degrees, because your K in this case is 0. K is 1, you still have an 8th root of 2. CIS, you just need to add 90 degrees because our K here is 90. So 56.25 plus 90 will give you 146.25. And I think the rest you guys know what to do here. I just leave it to you guys. You just 8 root 2 of CIS. This is Z2. And again, you add 90 degrees next. That will give us 236.25. And you add another 90 degrees here. That will give us 326.25. So you find out these angles that you find here, they all are in between 0 and 360, 1 revolution. Okay. So you just keep on adding. Same thing happens to all the stuff you did here. This is always between 1 revolution. So this is how we do this kind of questions. So this is the end of this section here. So yes, you will get questions in your test talking about this nth root. And you also will get questions in your finals talking about either De Moivre theorems or the multiply divide theorems here. So make sure you guys know how to apply this theorem in your test. And again, class, don't forget, you're allowed to bring 1 page of front page only to in your finals here. So I would highly recommend you to put down this nth root De Moivre theorems and all these multiply theorems here. So this is the end for today's class. Don't forget, Monday we will have a review of your finals, starting from 2 o'clock to 3:30, same time here. So if you have any questions, please do stay and I will help you. If you have no questions, you may go. This is